Hello, I'd like to introduce the work Neutrino emission from FRB-emitting magnetars. In this work, we studied the possible neutrino emission from FRB-emitting magnetars. During the magnetar flaring phase, it's possible that protons could be accelerated to higher energy, which would interact with X-ray photons to produce neutrinos through the photomeson interaction. We investigated the possible neutrino emission processes during the FRB emission phase. Since the FRB emission model is identified, we consider three possible scenarios, including emission from inside or outside the magnetic sphere, as well as in current sheet region beyond the light cylinder. We develop a generic approach that applies all three scenarios. Top calculate the neutrino flux from FRB 200428. We use an X-ray photon information based on the inside HXMT results as reported by Li et al. We derived the minimum required proton energy and the neutrino energy based on the X-ray cutoff energy. This figure presents the single event neutrino spectrum. The black curve is for neutrino emission in the magnetic sphere, and the green curve is for neutrino emission from relativistic shocks beyond the light cylinder. In order to produce neutrinos, protons need to be accelerated. On the other hand, protons also lose energy through various channels. Besides the P-gamma channel that produce neutrinos, protons also lose energy via various processes. For example, if proton acceleration happens in the magnetic sphere, they will lose energy via curvature radiation. Similarly, if they are accelerated in relativistic shocks, they will undergo synchrotron radiation energy loss. By comparing various cooling timescales, one can identify the energy regions where the neutrino emission dominates. This happens when the red P-gamma curve is above the other curves. We also calculated the contribution of all FRB-emitting magnetars to the diffuse neutrino background. The black curve is the case for nominal parameters, and the red curve is the most optimistic case. The blue data points are the observed diffuse neutrino by S-cube. One can see that FRB-emitting magnetars can contribute up to a significant fraction of the observed diffuse background. Thank you.